This video introduces the basic testing and maintenance of suction machines. This video was produced as an educational project and is not intended to provide expert information. Always consult manufacturer's information and qualified professionals before attempting to service your biomedical equipment. Always follow safety warnings. A suction machine is a medical device used to remove fluids like mucus, blood, or other secretions from a patient's airway or surgical site. Suction machines are essential during airway emergencies, surgical procedures, and wound care. The machine uses a vacuum pump to draw fluids through tubing into a collection container. Because these fluids are considered biohazardous waste, it's important to be careful while handling these machines. Suction machines work by creating negative pressure using an electric or manual pump. At the core of most electric pumps is an impeller, a rotating component that forces air out of the system. As the impeller spins, it removes air from the collection bottle and tubing, lowering the air pressure inside the collection bottle and tubing compared to the outside. The lower pressure in the collection bottle and tubing draws fluid from the body into the collection bottle. This is because higher pressure air flows toward areas of lower pressure. The more air the impeller removes, the stronger the suction becomes. The suction strength can typically be adjusted based on the specific application. For instance, neonatal suctioning requires low vacuum settings, while adult surgical procedures often demand significantly higher suction levels. Most suction machines include a pressure gauge and an adjustable control dial, allowing clinicians to monitor and adjust the suction level. Vacuum pressure varies depending on the situation. 60 to 80 millimeters of mercury for neonates, 80 to 120 millimeters of mercury for adults, up to 300 millimeters of mercury for surgical suction. Let's look at how to assemble a suction machine. Common suction equipment includes a collection bottle, tubing, filter, and a catheter, all connected to a suction regulator attached to the vacuum source. For suction to occur, the collection canister must be properly sealed to establish a vacuum. The collection bottles are what store the aspirated fluids until disposal. Their caps help protect internal components by preventing fluid from entering the vacuum system. This is achieved through either a float valve, which rises with the fluid level and mechanically shuts off the vacuum, or a hydrophobic shutoff filter that blocks airflow when it comes into contact with fluid. The filter, located between the suction tubing and the pump, also protects the internal components and prevents contamination. Be sure to use the appropriate connectors and tubing sizes, as these can vary between suction machine models. Typically, the patient tubing attaches to a designated port on the lid of the collection bottle, while a second hose connects the bottle to the suction pump, completing the airflow pathway. The consumables include the filters, catheters, suction swabs, and masks. Often, the collection bottle is a consumable, but some bottles are designed to be reused. The most common problem with suction machines is that the connections are not sealed. If tubing or lids aren't properly sealed, air leaks in and disrupts vacuum pressure. Always ensure everything is tightly sealed. If the suction seems weak but the motor seems fine, the low vacuum level may be caused by clogged tubing, a cracked collection bottle, incorrect connections, or a dirty filter. Another frequent issue is valve failures in the collection bottle, which can occur due to improper cleaning or accidental tipping. If the motor isn't functioning correctly, it may be caused by buildup of debris, insufficient lubrication, damaged parts such as the impeller, or an electric malfunction such as damaged wiring, a worn-out component, or a faulty power supply. Unusual noises during operation may also indicate problems with the moving parts or with the power supply. Start with the visual inspection. Tubing should be inspected for cracks, blockages, or signs of wear. If the tubing is stiff or visibly damaged, disconnect it from the device and replace it with compatible tubing of the same diameter and material. Clear tubing is preferred so clinicians can see the aspirated material. Make sure to choose the shortest practical length and ensure the inner diameter is at least 6 millimeters, 1/4 of an inch, to maintain proper flow. Inspect the collection bottle for any cracks or signs of damage. If cracks are found, Any glass or rigid plastic bottle with the same connections can be used as a substitute if necessary. Minor cracks can be temporarily sealed using materials like duct tape, petroleum jelly, rubber, or leather to help restore an airtight seal. To test the suction strength, place the tubing in a bucket of water and record how high the water rises in the tube when the machine is turned on. The height of the water column, measured in inches, can then be used to calculate the vacuum pressure using this formula. If the motor runs but suction is weak, inspect the impeller. Over time, the impeller can become worn, clogged with debris, or damaged. Replacing the impeller may restore normal function. To replace it, first disconnect the machine from power, then open the pump housing, remove the old impeller, and install a new one of the same type and size. Make sure the impeller spins freely and is properly aligned before closing the housing. Filters should be cleaned or replaced regularly. Some devices may require motor lubrication too. To clean a reusable filter, first turn off and unplug the machine. Then remove the filter from its housing, rinse it gently with warm water, and allow it to dry completely before reinserting. If the filter is disposable, replace it according to the manufacturer's instructions, typically after each patient or invisibly dirty. Some machines also require motor lubrication. Before doing this, always check the user manual to see if lubrication is recommended. If so, disconnect the pump from the power source and locate the lubrication ports, usually small openings near the motor, and apply a few drops of hot oil, 180 to 200 degrees Fahrenheit. Be careful not to over-lubricate, as excess oil can attract dust or damage internal parts. If present, remove the drain plug to flush out old grease. If all of the above steps have been completed and the suction machine is still not working, there may be a deeper electrical or mechanical problem. Consult your manual, a qualified technician, or manufacturer for recommended actions. Let them know what tests and maintenance you have performed. This concludes our instructional video. Thank you for watching.